regarding the quiz, we still did not fix a date for that, for the exams. I mean, we didn't fix a date for that. So I will let you know as soon as a date is available. Okay. So maybe next week, hopefully, inshallah. But I will let you know. Okay. So today we will proceed with our classes. We'll start with chapter 4. We will be defining what a nominal interest rate is and what is effective interest rate. So we will be defining what a nominal interest rate is and what an effective interest rate is. So just imagine this is the actual years. Now we're starting from 1, 2, 3, 4, 5, 6. 12 months, the actual months will make 1 year, okay? And then if we talk about actual quarters in a year, you have, if you divide it quarterly, then at each, you will have like 3 quarters in a year or something like that. So you will have 4, 4, 4. 12 divided by 3, 12 divided by 4, which will be equal to 3 or something like that, or 12 divided by 4 is equal to 3. So there are some new terms that we need to define. Number one is interest period. And when we talk about interest period, we are saying period of time over which interest rate is expressed. So the time period when you express your interest rate is called interest period. So like you say 12% per month. So the interest period is monthly, yeah, or 12% per year. So now we are talking about yearly interest rate. So interest period is the time over which the interest is expressed. Then there is this new term which is compounding period, CP. CP is the shortest time unit over which interest is charged or earned. So you imagine you take a loan from the bank or something, then they will be charging you, they will say annually they're charging you 12%, but every month they charge you something. It's not like they charge you always only once in a year. Maybe they charge you every month. So this small time interval, not the big one, the yearly one, the small one, which is the monthly one, is called the compounding period. That is the shortest time unit over which interest is charged or earned. For example, 10 per year compounded monthly. So 10% is collected annually, but compounded monthly. So the compounded period is monthly. I hope this is also understood. Then the next one is the compounding frequency. Compounding frequency is the number of times compounding occurs within the interest period T. So the number of times that you have this kind of compounding in a time period T. So let's say your interest rate is 1 year. So for example, at I, interest is 10% per year, compounded monthly, that is, they are collecting it monthly. Interest period will be compounded 12 times. So if they are charging you monthly, now the frequency M is 12 times. That is, they are taking this and they are compounding, collecting their interest rate 12 times in a year, because how many number of months in a year? 12 months. So that is the duration, the frequency in which they are compounding their interest. So a nominal interest rate, this is another terminology that you need to understand. I mean, I don't know the modes of the questions, the exams questions, but if at all you'll be asked any question related to MCQs, that is a definition way, and these are the words that you need to remember. But if it is calculation wise, then we will also look at some examples that are mathematical in nature. We'll look at them shortly. So there is another terminology which is a nominal interest rate R. This is another term that you need to be familiar with. So this nominal interest is obtained by multiplying the interest rate, that is expressed over a short period of time by the number of compounding periods. That is the nominal interest rate. You just multiply the interest rate that is obtained, maybe the monthly interest rate or whatever, then multiplied by the number of periods that they are compounding the interest rate. Let's say I is equal to 1% per month, then the nominal rate per year is 1 multiplied by 12, that is 12 months in a year, and then you'll have 12% interest per year. So this is it. For example, if they are collecting 1% interest rate every month and you are asked to find the nominal interest rate in 1 year, all you have to do is multiply the 1%, that is the monthly percent, multiplied by the number of months they collect it, that is 12 months in 1 year. That is why you have 12% nominal interest rate every year. Then we look at a new term, which is effective interest rates. It takes compounding into account. So this effective also takes compounding into account. Effective rates can be obtained from nominal rates through the formula that we'll look at in shortly. So there is a formula that you use to calculate these effective rates from nominal rates. So if you are given nominal rates, you can be able to calculate these effective rates. So for example, we will look at the formulas here. So if you are given a nominal interest rate, and you just plug it here and calculate the effective interest rate. So we'll look at it. So nominal interest rates are essentially simple interest rates. So they are almost similar when we talk about nominal interest rate, because simple interest is just the interest you take annually. Yeah, maybe they will say you just take one interest rate in a year, so they are almost the same. It's just like you are talking about the same thing. You said you want me to explain compounding. Okay. So compounding period is the shortest time over which they charge you an interest rate. So now, if you take a loan of a car from the dealer or from the bank, normally they will tell you in the paper, they will write that they are collecting and they are giving you this car for an interest rate of 5% annually or something like that. But what they do is every month they deduct some amount from your salary. So this monthly deduction is known as the shortest time that they are compounding. That is the interest compounded monthly. They're taking the interest rate monthly from your distance. So the compounding frequency is number of times they take it in a year or something like that. Okay. So they express the interest rate over a certain period. They give you the commodity at an interest rate of 1% per year, but deep down they take it from your salary every month. So that is just the simplest explanation of this compounded interest rate. So nominal interest rates are almost similar to this simple interest. Therefore, they can never be used in interest formulas. Effective interest rate must always be used here after in all interest formulas. Okay, these are all just notes that we will look at them in details. So more about interest rate terminologies. There are three ways to express interest rates as shown below. So normally the language they use to express interest rates, they say it, they express it in these ways. So it's either they will say interest is equal to 2% per month or interest is equal to 12% per year. So that is it. They can either tell you interest is equal to 2% per month, or maybe they will tell you 12% per year. That is when there is no compounded period is given. So when there is no compounded period, maybe they did not tell you that this is collected every time for this number of years, then the rate, you just assume that this is an effective interest rate. That is it. It is a total interest rate. But sometimes they tell you, they use the word compounded, yeah? So let's say interest rate is 10% per year. For example, they can use this language. They will say interest rate is 10% per year, compounded semi-annually. That is, it is taken from you semi-annually. That is twice in a year. That is just, I will show you an example, a table that talks about all this annual and semi-annually. Like if we talk about semi-annually, it means it is twice in 1 year. That is annual is annual, and semi-annually you just attach to semi-annually. Quarterly you have four times in 1 year. So we'll look at this table in details. Um, Also, they can decide to say, okay, I is equal to 10% per year, compounded semi-annually, or I is equal to 3% per quarter, compounded monthly. So these are just words that English language words that they use to describe how an interest rate is charged. So when this happens, when compounding period is given, like the way they are giving, telling you compounded semi-annually or compounded monthly, and it is not the same as the interest period, then the compounding is not the same as the interest period the way it is now here, then it is a nominal interest rate. Okay, so these are all ways you try to understand when whether this is a nominal interest rate or an effective interest rate. For example, if a question is given a calculation and they did not tell you this is an effective interest rate that is given or this is a nominal interest rate that is given, then you look at this, the ways they express the interest rate, and you deduct from that whether it is a nominal interest rate or an effective interest rate. And the third scenario is I is equal to effective, and maybe they will say this is an effective interest rate now. They will say I is effective 9%, 9.4% yearly, and they will also mention compounded semi-annually. So they mentioned the word effective, and also they mentioned the word compounded. Okay. And when compounding period is given and the rate is specified as effective, then the rate is effective over the stated period. So it is effective rate, interest rate. So if they give you a question in this format, then what they are telling you is the interest rate is effective. So this is easy. You can easily see it. If they give you an interest rate and they give you the compounding term, and the compounding term is not the same thing as the interest rate, then the interest rate that is given is a nominal interest rate. If they give interest rate without any word or about compounding, then the interest rate that is given is an effective interest rate. This can come up in a multiple choice question also. Maybe they will decide to twist this question and ask you if an interest rate is given and a compounded terminology is given. Is it an an effective interest rate or a nominal interest rate? Of course, it is a nominal interest rate. So, and also I believe the exams will be something that maybe all of us can propose some questions. And for me, I believe this kind of definitions are better expression of better ways to test whether you understand what the material is all about. Because at the end of the day, once you are done with this engineering economics in the bachelor's, then I don't think you will ever meet it again. And normally, the engineering economics I will be expecting is a course that will give you the opportunity to calculate like efficiency of using some certain types of materials in the industry, like to compare a technical and economic perspective of using different types of materials and some feedstock and so on in producing some commodities in the industry. But unfortunately, it is not like that. During my time, what I did is completely different from what is given to you guys. So this is a formula that you can use to convert nominal interest rate into effective annual rates. So if you are given a nominal interest rate and you are given a period of time, so you can use this equation to calculate the effective annual rate. annual interest rate. Okay, so this IA in this formula is an effective annual interest rate, and I is an effective rate for one compounding period. So if they give you a compounding period, for one compounding period, you take it as an I. Then we will look at an example shortly. How to use this. This M is the number of times the interest rate is compounded every year in 1 year. So maybe if the compounding period, if it is compounded semi-annually, then this would be 2. It is compounded quarterly, it will be 4, and so on. So this is an example that shows how you can do this kind of calculation. So for example, they said for a nominal interest rate of 12% yearly per year, that is the nominal interest rate now is given. Determine the nominal and effective rates per year. Okay. For quarterly and monthly compounding. Okay, so they are giving you this nominal interest rate per year, which is 12%. And then if you want to find the nominal quarterly interest rate, you just divide this by the quarter, which is 4. Yeah, you divide the 12% by 4, and it will give you 3%. And now you have the nominal quarterly interest rate. Okay, so you can use this nominal quarterly rate and plug it into this formula to find the effective interest rate, quarterly effective interest rate, which is 1 plus the nominal quarterly interest rate, which is 0.3%, and that is 3%, 3 divided by 100, and then your M is 4 minus 1 from this formula, and this is what you have. And then the nominal monthly compounding that you are asked to find, the second one, is nominal month over month. Now this is per year, yeah. That is the quarterly. That is why you divide it by 4, because it is quarterly. Now you are dividing it, the yearly one that you're given, you're dividing it by 12 to get the nominal interest rate monthly. So it will be 12%. Divide by 12 months, which will give you 1% every year. And if you use this to find the effective interest rate in every month, given this compounding, then you just use 1 plus the 1% for 12 months minus 1, which will give you 12.68%. Then another scenario is when you are given a nominal interest rate, so you can convert the nominal interest rate into effective interest rate for any period of time using this equation. So using this equation, this is a more complex, complete equation that you can use to convert the nominal interest rate into an effective interest rate for every given period of time. So I is an effective interest rate for any time period. R is the nominal rate for some time period. And then M is the number of times the compounding occurred for a specified period of time. So now example is for an interest rate of 1.2% monthly. So they are giving you a monthly interest rate. In the other question, they give you the yearly interest rate. Now they're giving you a monthly interest rate. You are asked to determine the nominal and effective rates per quarter and per year. So if you want to find the nominal rate per quarter, then you do 1/2 divided by multiplied by 3, so that you will get it in quarter. Yeah. So because you have 3 quarters in year, so 4 times 3, which will give you 1 year. So if you do the multiplication, it will give you 3.6%. And now effective interest rate, you use this formula, giving your R, which is the value, the rate you found just now, over M, which is 3 times raised to the power of 3 minus 1, and it will give you this one. And then per year, you multiply it by 12. That is the monthly, you have 12 months in 1 year, you multiply it by 12, and then the value you use it. You plug it into this formula, you raise it to the power of 12, and you get your rates. So this is the table I'm talking about, because you see here they are talking about quarterly, they're talking about semi-annually, some questions and so on. But if you have this table, it will guide you with the language. So if they talk about quarterly, in 1 year you have 4 quarters. Yeah, semi-annually you have two times. Daily it is 365 days, and daily is 1 day in 1 day. In 1 week you have 7 days. Yeah, and so on and so forth. So this, I believe, this also you can use this table in the exams if you want, but I don't think it will be that complicated. This thing. So sometimes the interest period would be too small. So for large, if you are dealing with large kind of transactions, then you discover that the interest rate that will be given to you, the interest period will be too small. That is, the interest period is compounded continuously, almost, you can say. So they almost collect the money batch by batch, maybe weekly or maybe something like that. Therefore, in this case, the so actually I wanted to stop somewhere around here, but let's just complete it. So therefore, payment period is greater than compounding period, and M is increasing. I mean, if the compounding period is a lot, that is the interest period is very small. That your compounding is very. This slide is not well captured. It did not capture what I really want to explain to you guys. So maybe we will just leave this guy until the next class. I thought I already made a new slide, but this is the old slide that they gave me from the department. So next class we will just continue from this compounding from this scenario when you have continuous compounding, and then we will look at some examples under it. Okay. So again, regarding the exams, I will let you know, and maybe it will be next week or so. Whatever the case, inshallah, I will let you guys know. So I hope all is understood. Yeah, the as I was saying, I mean, during my time, the kind of engineering economics that we did was much different from what they are giving or what they are giving you guys now. So normally they will give you a scenario in the industry, and they will ask you that can we, I mean, if you want to produce maybe a pancake, and they will say, you choose either you use almarai butter or another butter from another company, which one will give you better profit and then will be more efficient. So these are the kind of engineering calculations that you do economically to see which one is better for you. Not this one, I believe it is more of a pure economics than to say it is an engineering economics, although it is taken from the book, but I don't know. So I hope everything is understood. Okay, guys. If there is no any question, then you can have your time. You will have a nice time, inshallah.